this session. It's actually might be my second time speaking at Refactor Tech. With the pandemic, I honestly can't remember. My name is Cecily Poole. And in this talk with The Future is Reactive, I'll talk a little bit more about the Java Reactor Core library, just because it's something that I personally have a love-hate relationship with, but I know that Java is going to be embracing reactive programming and reactive core quite a bit in its future. So I figured, why not share with all of you why I love reactive programming, why I hate it, what it is, and hopefully you won't have as hard of a time adopting it as I did. We'll go through some examples of reactive programming as well. So because I love audience participation, I actually have a Slido where I'm curious to know everyone's placement with their familiarity with reactive programming or reactor core. So, oh, there it is. You can go to slido.com and put in this hashtag RefactorTech22. Don't use the QR code. I forgot to change that. You'll probably be taken to the wrong link. So sorry about that. I forgot to update that. It's my third time doing this talk this year. You'll probably be taken to a previous conference. So just use the slido.com and the hashtag RefactorTech22, and that will take you to where you can ask questions throughout the presentation. So if you don't want to raise your hand, that's perfectly fine. You can ask questions in Slido, and it's also where the poll is as well. So, sweet. Knowledgeable. I bet that knowledgeable is you, Anthony. Are you cheating? Okay, great. I want more beginners, more people that are like, what's reactive? And there's no experts. So I was certainly going to have any expert come up here and do this talk because I for sure am not one. I am knowledgeable, but I'm certainly not an expert. Oh, this QR code should work. So try that QR code. All right, we'll come back to this as y'all are doing that. But more about me. So I am currently a senior software engineer, and I have been programming for over a decade now. I got my bachelor's at Georgia Tech in computer science. I've worked at places like MailChimp, NCR, Cox Communications, and I'm also a LinkedIn Learning instructor with 4 courses now live all around Spring and Java. All right, there's not that many of y'all, so you probably have the final results now. Cool. Yeah, reactive what? We have some novice, some beginners, and a few knowledgeable people. So this is I would say out of all the times that I've given this talk, this is the most diverse group of people with their experience with reactive. Usually it's reactive what and beginners when I've given this talk in the past. So cool. We'll see if y'all can learn something new. In this overview, I'm going to talk about why we should even care about reactive programming. Why am I up here telling you about this? We'll also talk about what it is. We'll define some key terms. I'll go over an actual problem example as well as a coding example deep dive. I'll share some key takeaways that I have from just doing this entire experience, as well as question and answer. So for my beginners and novices, you will probably look at this code and probably say, what the heck is going on? This was my first experience when I first saw reactive programming. This is a nonsensical example. My challenge was to try and use as many of the random operators and words that you may come across in the reactive core library. We're not going to go over this example, but I just wanted to illustrate that just looking at this, it's sometimes not very readable, and sometimes you might not know what a flux is. When I first heard of a flux, I'm like, is this a Dr. Seuss thing? Like, that's the first thing that I thought of when someone said, let's create a flux. We're not in Dr. Seuss land. I have no idea how they came up with that name, but that is an actual object, and we'll talk about that later. So, like I said, I have a love-hate relationship with this. I realized in looking at reactive programming that I couldn't avoid it. My main realization of this is working with Spring's web client. They are actually in the future going to be supporting WebFlux. So right now there's two ways that you can do a web server with Spring. You can either use Web Client, which is the blocking version, or you can use WebFlux, which is the reactive programming version. Eventually, at some point, the web client may actually be deprecated, which means I'll have to understand how to use fluxes. I'll have to understand reactive programming. I don't know when they'll do that, but that is the future that we may live in one day. And I could not avoid something that I hated just because I didn't like the way it looked, I didn't understand it. So let me try and understand it. The first place that I started with that was the Reactive Manifesto. One of my colleagues is big into reactive programming, and he sent me this URL, reactivemanifesto.org. And I feel like this is a good place to start because it answers the question of why should we care about reactive programming. So within this manifesto, it talks about at high level that our systems should be reactive by being responsive. They should be consistent, high quality applications that can detect problems and quickly manage them, but also continue to build user experience. They should be resilient, and they should stay responsive even during failures. That should be compartmentalized and not compromise the entire system. So just because one piece goes down doesn't mean your entire system should go down. They should be, oops, clicked the wrong button. They should be elastic, meaning that you want to be able to scale your resources accordingly. And the last and probably most important piece is that they are message driven. They leverage non-blocking communication and asynchronous message passing. This last piece is really where the reactive programming comes into place. I like to think of it as with reactive programming, you can embrace message driven development, which in turn makes your application more responsive, more resilient, and more elastic. I encourage you to read the rest of this manifesto. It's pretty interesting. Even if you don't go all the way into reactive programming, there's still some key things that you could take away to make your application more resilient and elastic and all these wonderful things. So, reactive programming, what it is a coding style that is non-blocking and embraces asynchronous events. This means that when you have a thread, that thread isn't going to wait for a piece of work to be done. You're actually going to be able to do multiple different things at the same time. It also revolves around routing and consumption of events. So this makes us have to ask the question in our application, what is the event that we're trying to create? What is the event we're going to try and send? And what is the event we're trying to consume? So we've talked about this in a very high level, abstract way, and let's try to make this more concrete with my problem example. Let's say that we're trying to build a system for this conference, and we have a database of conference registrations. So each one of us are guests at the conference. We have some downstream systems that would like to know every status change for a guest. So when a guest is registered, when a guest is checked in, maybe even when a guest decides to cancel, that downstream system wants to know every time that change happens. And there's a second downstream system that just wants metrics. They just want to know how many guests are in each status for whatever reason. Those downstream systems don't want to poll us, though. They don't want to have to constantly ask us, how many users or guests do you have now? This also means that we have little control over the database. One way around this is if we have access to the database, every time, let's say with Postgres, you might have an event trigger. So every time something is edited in your Postgres database, that's a very easy way for you to send information downstream. But let's assume we don't have that functionality. We don't have that ability with this database. It's a read-only database. So that means that we actually have to pull the database ourselves every so often to get this information downstream. Another key piece is we don't want to pull information endlessly when no one even wants it. If no one's listening to it, subscribing to it, why waste the cycles and the resources and the energy when no one wants it? So all of this problem is a great use case for reactive programming. There are actually a lot of interesting operators that we can use within the Reactor Core library that make something like this pretty simple to implement. Before we get to the code, let's go through some key terms. So the first two key terms are probably one of the most overused terms in technology. We have publisher and subscriber. Publisher, of course, publishes events, and subscriber subscribes to those events. That's a very generic way. It will get more complicated later, I promise. The one thing of note is that the publisher is an interface, and that Flux that I mentioned earlier and the Mono, they implement this publisher interface. So Fluxes are publishers that represent an asynchronous sequence of one or more events. Monos implement the publisher as well, and they represent an asynchronous result of 0 to 1 event. I have no idea why they had to have two different objects. I'm still waiting to understand what the benefit is. I haven't come across one where I'm like, oh, it makes sense that this is just a mono, makes sense this is just a flux. But that's the difference between the two. Mono has 0 to 1 objects, flux has one or more. The last key term is operator. So the operator adds some behavior to a publisher and does a piece of work. It could also help you translate a mono into a flux into a mono. There's a lot of different operations that you can do with all of your publishers and subscribers, and we'll see some examples soon. My last piece of setup is if you ever look at the Project Reactor website and the documentation, you'll likely come across these marble diagrams. So I'll be showing you some diagrams that are loosely based off of this, but understanding these diagrams have been crucial when understanding what a flux is doing, what an operator is doing, what have you. There's a link down here, how to read the marbles, that is very helpful to kind of help you understand how to break all of this down. My diagrams are loosely based off of this. It's not exactly the same. Okay. So here's the first visual. Hopefully everyone can see this just fine. In this example, at the top, we have a timeline from 11 a.m. to 11:18 a.m. And as we move down the page, this is what is happening. This is how we are translating our fluxes into other fluxes, what we're operating on. So my hope is to illustrate to you that these events are not happening all at once. These events are happening at various times. So for example, let's say at 11 a.m., we have someone subscribe through our application and say, send me some events. 2 minutes later, because we just have a ticker of a flux, 2 minutes later, we emit this long value 0. We pass that long value into our operator, and we map that long value into an instant to represent 11:02 a.m. We are going to eventually take this flux of 11:02 a.m. and all of our instances and pull the database ourselves and turn that into more fluxes and more information downstream. We'll get to that as another example. Looking at all my notes, make sure I covered everything. Okay. So this is a second diagram showing that 2 minutes later at 11:04 a.m., we emitted 1 as a long value. We passed that into our operator and turned that into an instant. This final view shows every single flux, every single event of our long instant flux, as well as what we're mapping them to in our instance. We are only doing this every 2 minutes, so we're not getting all of these events at once. Now, this bottom flux, which are just a flux of instance, we can now take that and pass that into another operator. So the ultimate goal is to use that 11:02 a.m. event, go to the database and say, give me all of the guests who were created before 11:02, or give me all of the guests who were updated before 11:02. And we can do that with another map operator, actually 2 different map operators. So on the left, we have a map operator for guests created before a certain time, and we have on the right our map operator for guests updated before a certain time. You'll notice not every single event is actually being used because we don't have any guests that were created or updated between 11:02 and 11:08. So all of our 8 events up here now get translated into 5 different events across 2 different fluxes. Now, we ultimately want one flux, and we want all of those events to be ordered. I want to be able to see that you were created at 11:02, you were updated at 11:04, you were created at 11:05. Right now, it's split between created and updated. This leads us to yet another operator called concat_map. With this operator, you can take multiple fluxes and merge them into one, and it will still respect the order of the events. So now I can see at 11:01, my user was created at 11:07, and it was updated at 11:09. Another one created, another one updated. Cool. So now that we have a flux of all the events that we want, we now want to get this into a format that our downstream users will be able to subscribe to. And we can do that by transforming our regular flux into a connectable flux. We do that through our publish operator. So a notable difference, they're both fluxes, but the main difference between the two is what kind of operations you can do on them. So we can obviously call the publish operator on flux, but with the connectable flux, there's a different set of operations. The main operation that we're going to talk about is ref count. So I'll go into another illustration of what ref count means as an operator. So at the top here, we have our connectable flux of all of the events of our user being created and what have you. And on the left here, I'm illustrating that a subscriber subscribed to our connectable flux. When we are using the ref count, this is effectively a way to control the behavior of our connectable flux. We want to be able to tell the flux if a subscriber cancels at any point in time, and if it's before our grace period, just keep the connection alive. We might get another subscriber. If we lose all of our subscribers and the grace period passes, go ahead and kill the connection. Don't do anything until another subscriber comes in. Okay, so I'll walk through this example a little more. We have our subscriber 1 subscribed to 11 a.m. At the bottom, our subscriber gets the 11:01 created user. We have a second subscriber subscribe shortly after that, and both subscribers get the next create event. For whatever reason, subscriber 1 decides to cancel, but subscriber 2 still gets the next emitted event. We lose both of our subscribers, but we still have a grace period. Let's say we set the grace period for 30 seconds. So we still emit this event, but nothing gets translated down to any downstream subscribers because we don't have any. Our third subscriber, right within that grace period, goes ahead and subscribes, and they immediately get the next event. Now, this ref count is important for a couple of different reasons, and I actually have a whole section later, but I covered a lot of things, and I want to talk about the code before we learn even more things. All right, code dive. So I have a Java Spring Boot application. It's Java 11, I believe. It was before I started using Java 17. And it has an H2 in-memory database. I'm using Lombok, so if you recognize the @data annotation, first of all, let me see. Can y'all read that in the back? No? Okay, let me see if I can quickly increase the font. There we are. Would it also help if we turned off the lights? All right, is that better? Sweet. Okay, so where was I saying? So line 11, we are using Lombok. We're also using the JPA library with the entity and add ID and generated value. So this object is our guest model. This is what's being stored in our database. We are tracking the guest statuses. So this is the enum of if they were registered, they canceled, absent, what have you. And we want our guest information to be translated into what I'm calling the registrant change object. So this is what we want our subscribers to receive. We want to give them the guest ID so that if they want, they can call our API again and get more guest information, and they also get the status. We also have a controller, very basic not at all perfect. Great for conferences, not for production. So we have our guest repository. Again, this is how we're accessing the database to create guests, update them, and also retrieve them. So it should not be anything surprising if you're already familiar with Java and Spring. We have our create, update, and read endpoint. But the new thing is the subscribe post method that I have here. This is how I want our downstream subscribers to subscribe to any of the changes that we are emitting. And I'm using something called the event emitter, which I will walk through next. Our event emitter at the top here has a flux of changes on line 13. Within our constructor on line 20, we are creating that flux of changes. We are first on line 20, starting off that ticker in the example of every 2 minutes emitting a long value. So this line is doing the exact same thing, except I have it every minute because I don't want to stand here for 2 minutes showing you this example. So every minute we are emitting a long value. On line 21, we have our map, and we're taking in the long value represented by this L variable. And notice we're not using it at all. I'm cheating. I don't want to, there's probably a better way that I could emit an instant every minute, but this is a quick and easy way for me to accomplish that. There's probably a use case where, let's say, you want to take that long of 0 and do some kind of math with it. So maybe you might want to subtract it from the minutes or do something else. I'm not using the L value at all. I am just saying, give me the time now for the past minute. The next line, line 22, this is where we are concatenating both of our two fluxes that we're going to create. And this is coming from our load changes method. So all this load changes method is doing is calling two other methods and concatenating them into one single flux. So scroll down a little more, we have both our load updates and our load creates method. You would think that they're doing almost the exact same thing. They are. We're finding all of the updated users since a certain instance, and we're finding all of our created guests since a certain instance. But if you look a little closer, there is a deceptive difference between the two of these. Can anybody tell? The spacing and indentation could be a dead giveaway. No worries if you don't see it, because it always takes me forever. No. Okay. So here on line 33, I'm using the flux from stream. And this flux from stream takes up from line 33 to line 36. So the entire input for the flux stream includes getting a list of guests from line 33, returning that list of guests into streams, and we're mapping that list of streams of guests into the registrant change. Now, if you notice for this method, we're using the from stream still, but the map is different. We were calling the map here on Java Stream API, whereas the map here is the Flux API. This is a minor difference, but it makes a difference as you're writing code. So like, you know how you have type ahead in IntelliJ and you put a period and you're like, okay, now I want to do this next Flux thing. I can't find it. Why can't I find it? It's because I simply moved the parentheses. That's it. Moving the parentheses can change what API you are currently using at the time. And it's very confusing since they are so similar. And that's one thing to really pay attention to as you're writing code, especially in a code base that uses both fluxes and streams. Sometimes you just have to pay attention to where is that parentheses placed? Am I using the API that I'm expecting to be using at this time? And there's probably some other differences. I haven't looked into this, but there might be some other differences in terms of performance, for instance, versus doing a map on Stream API versus doing the map on the Flux API. I'm very curious to know if there is some kind of performance difference in that regard. But I intentionally did this to kind of just throw you off because it's something that I experienced a lot, and want to be sure that you're aware of it. All right, so in this method, we are taking a stream, however we decide to create that stream, and mapping it to registrant change and returning it into a flux. And that is what's being concatenated on line 28, and that is what we are concat mapping on line 22. On line 23, we see that we're calling the publish, and our flux registrant change from line 22 now turns into a connectable flux. And then finally, on line 24, we have our ref count, where I'm saying I want at least one subscriber, and my grace period is 30 seconds. All right, so that's all of the code that I have here. And I already have this running. Sweet. Nothing has been printed out yet. And in Postman, I want to go ahead and subscribe. So I'm calling my guest subscribe here. How am I doing on time? Sweet. So now I am subscribed. I should now see some logging here from Flux on subscribe was called. And now if I were to create a guest, Cecily Poole registered, go ahead and create that. Wonderful. And let's say I've honestly been absent. Well, also because it's a different name as well. That's why I was absent. Anyway, in a minute at 11:28:23, which should be, where are my seconds? In about 20 seconds now, we'll finally see a create event be logged and an update event be logged. 1, 2. I know it works. And there we go. Perfect. So you can see that guest ID 1 was created and guest ID 1 was then updated. So seems like a simple code exercise. But like I said, there's a lot of nuances within this example. One of the things that I wanted to talk about was the difference between a cold publisher and a hot publisher. The code example that I just gave is actually one of a hot publisher, where a subscriber receives events after they are subscribed, but it's not from the beginning of the set of events. The cold publisher, which I'll illustrate next, you actually start all over again the next time that a subscriber is subscribed. So in this example, at the top, we emit a long value of 0. Subscriber 1 gets 0. Subscriber 2, when they subscribe, instead of also getting event 1 that subscriber 1 is seeing, subscriber 2 gets the very beginning of the event. And that behavior continues even after we drop all of our subscribers and subscriber 3 is subscribed. This is an illustration of a cold publisher. For a hot publisher, this is what I have already illustrated, where as soon as a new subscriber comes on, they receive the current event. They don't receive the beginning of the events. I will say, though, that the grace period is one of the ways that you can kind of control switching your publisher from cold to hot behavior. So if, let's say, we lose all of our subscribers and the grace period had passed, the very next subscriber would actually get the beginning events rather than the latest event. I also cheated in that I am referencing time in the example. So there's no such thing as beginning of time. There's no such thing as like go back to 11 o'clock. I'm always saying give me now minus 1. So even because our subscriber misses the grace period, they're always going to get the very next event. Hopefully that illustrates the little nuances that you can have in the behavior of your flux. If you just by determining what your flux is emitting, that can change your flux, your publisher, from a hot publisher to a cold publisher. There's also a number of operators that allow you to do this. You are able to switch from a cold publisher to a hot publisher by using the share or publish operator, just like what we did in our example. But you could also go from a hot publisher to a cold publisher using the cache operator. I haven't used the hot to cold quite yet, but there are specific use cases where you might need a cold publisher for a certain period of time, and you need to translate it to a hot. It really depends on your use cases. That, again, gives you some nuance and a lot of control over this behavior. It also can lead to a lot of confusion and misunderstanding because you may think that it's a hot publisher, but because of that one little nuance, it's actually a cold publisher, and that makes debugging a little challenging. So, final thoughts. After doing this deep dive, there are some things that I've learned, and I think hopefully you will agree with. The first is that there's a lot of situations where reactive programming can actually be helpful. So, like with that scenario of the database being read-only and needing to do something like that, it was fairly simple to do with an asynchronous reactive programming code base. It can make your code base actually a little simpler, depending on what you're doing. I also realized it's something that I'll never stop learning about. Like I said, this is just the tip of the iceberg of all of the nuances within reactive programming. I'm sure there are a lot more, and there's still a lot of gotchas that I want to learn and understand, so I know how to deal with them and solve them. And this leads me to number 3. If you're not careful, it can bite you in the butt. So you probably did not pay too much attention to this, but we actually had some warnings in IntelliJ around the find by updated at. And this is because IntelliJ is complaining that we're trying to do a blocking call to our database in a non-blocking context. And that could lead to threat starvation and cause, of course, problems. So the solution to that is to actually use a database that supports reactive programming and would actually emit Flux. And I believe there is a version of the JPA repository that is now reactive as well. But that's just one of the things that if you're not careful, it could bite you in the butt. You can have production go down for some reason because it's run out of threads, and this could be the reason. And let me go back to the presentation. Finally, I also learned that reactive programming and I will forever have a love-hate relationship. There's just no getting around to actually loving reactive programming. It's caused some problems in my life, but it's also caused a lot of learning, and it's just a great experience to kind of see some pretty interesting and cool things happen just in a few lines of code. So hopefully you will have some healthy amount of skepticism around embracing reactive programming. So, questions. Let me see if there were any questions on the Slido. Nope. Cool. No questions? Yes, Anthony?
Yeah, so toward the beginning you mentioned I think it was concat map method. And that might be concatenates the fluxes, and you said it respects the sequence of events, right? But then when I saw your code, you called that method, but you passed in another method that was doing concat. So what's the difference between those two? Yeah.
So concat is not going to respect the order. It's just like smushing them together. Whereas concat map is actually going to allow me to have the order that I want. And I wish they had better like documentation within these things, but c'est la vie, they do not. Any other questions? Yes.
I don't know anything really about Java, and I was just curious, like, what is the difference between these public and private, I guess they're functions?
Oh, yeah. Public and private methods. So this is a method that I will only be able to access within the event emitter itself. Whereas this is the constructor. So I'm basically saying anything will be able to create this event emitter. Do I have other examples? I think this is the only place I have private. So all of these methods are public because I'm saying anything outside of this will be able to access it. You can also use public and private for access to your objects themselves. So this event emitter I'm saying is private because I only want everything within the controller to access the event emitter or to access the guest repository. So in order for anything outside of this controller to get access to this, they would have to call our public methods to do so. Does that make sense? Okay. Any other questions? Yes.
If we've got some extra time, I'm really interested. Have you experienced the reactive with using like the pushback and the ability to sort of do self-healing? I hear about it.
Are you talking about like back pressure? I have not had to dive into back pressure. Back pressure is, I would say, another can of worms where you are able to, from what I've understood so far, you are able to kind of control the frequency of the events in a way. So like, let's say in here, I think I can just call back. So there's a variety of back pressure related methods. We're like on back pressure drop. So I think this one I've only seen once, and I believe this method was to say if the subscriber isn't handling the events well enough, just go ahead and drop the events. Whereas the buffer, I believe, is like even if the subscriber can't handle all of the events, go ahead and buffer some of them until a configured point in time. I haven't seen back pressure error or latest, but the reference guide for Project Reactor, let me see if I can open that. Where'd you go? My window just disappeared. Oh well, I'll bring it back up. So Project reactor.io/reference guide. I've had to come to this quite a bit, and it's a very helpful documentation where it's in here somewhere where they go into detail about back pressure. Handling errors, peaking. Let's see. Nope. Back pressure. The ability for the consumer to signal the producer that the rate of emission is too high. Yeah. Does that answer your question? Somewhat? Yeah. Yeah, there's a whole section here on it, and it's something that I haven't really had to play around with too much. Someone else had a question? Yes.
So now that this is an async model, do you ever have to worry about like race condition?
Oh, yes. Yes. Especially if you're in a code base that's kind of mixing blocking and non-blocking code, that's definitely where you're going to see that.
Does that like change how you have to go about writing your application?
Usually first there's like a decision of do I want this activity to continue to be blocking? Is there a reason that turning it asynchronous is just not a good idea? I prefer not to mix the two, because at some point when you start doing asynchronous programming, you're going to get into this place of having to translate it from blocking to non-blocking. And like, you might run into situations like in the code here where IntelliJ is mad at you because it's like, you're calling a blocking call right here, but you're in an asynchronous context. So you have to be careful of these scenarios. So my first thing is like, do I want to really mix the two? Is there a way that I can avoid mixing the two? If not, can I go all in on asynchronous programming and maybe have the entire feature or the entire piece of code be asynchronous so I'm not running into this potential issue? So I don't know if that helps, but it's definitely a problem that a lot of people continue to have, especially with older code bases that are blocking, or they might be using, an executor jobs, and like they want to turn that into asynchronous. It's something that you just have to kind of evaluate your code base, evaluate what it is that you're trying to make asynchronous, and figure out the best way to do that. So there's not a catch-all, this is exactly how to do it. I would love to know if someone has a formula for that, because I haven't figured it out. Any other questions? 4 minutes, yes.
I'm curious what your debugging flow is like. Like, let's say there's something you're trying to debug that's like buried in a very complicated flow.
The last time that I had to debug something, I actually ended up ripping it out. And it was a situation where I was calling another microservice that wasn't reactive programming, like it was blocking. And it just could not, it seemed like it could not handle the amount of traffic that I was doing with the asynchronous calls. And it was just causing a lot of problems. And I tried to debug it. I tried to understand, like, what is it? I think the ultimate solution was to make the service that I was calling be reactive programming, or have some endpoints that would return fluxes for me so that I was not running into that issue. But I ultimately was like, it's not really worth the headache to try and figure that out and to do that level of work. With some of my simpler things that did not cause as many problems for me, logging has been very helpful. So in the, not this one, where is it? It's in the controller. You'll actually notice that I have this log method here. And that is why we actually see every activity in here. So because of that log method, I'm able to see what was emitted and when. That has been very helpful, as well as if we go back to here, they actually have a section around debugging. So you usually have to go back to this to try and figure out some tips and tricks to better debug things if the logging isn't working, if what I already have isn't working. 2 minutes. Any other questions?
Would you try, I mean, it sounds like you're able to use your Flux within microservices,
Mm-hmm.
so you're not having to try and tune the Flux to respect certain boundaries it can use as much. So you know, basically you tune the microservice, not the Flux, right?
Are you talking about with the example that I gave earlier about how my Flux would, I tried to tune the Flux. I actually tried to do retries. I tried to do, I think I even tried to do delays. I've tried to also, another solution would be to have a bulk call that I could have made to the microservice rather than like a single call, because that would have not have hit the service as much, because I was sending, I can't even remember what it was, but it seemed like I was sending just way too many requests at the same time, and the service just could not handle it. I tried to tune the number of instances on the service itself that I was calling to see if it could better handle that amount of traffic. It depends on like what it is that you're trying. If you own the service yourself, it might be easier to just go ahead and update that microservice so that you don't have to do the whole Flux tuning thing. But yeah, I was just trying to embrace Reactor Core, and I was like, I could do this with Reactor Core. And ultimately, I was like, I'm gonna go back to blocking. There's just a lot to it, especially when you're in a space where not everyone is asynchronous quite yet. It can just be difficult to truly adopt it. Cool. And we're at time. Thank you. Let me know if you have any other questions.